Okay, 7.6 is all solving equations. Everything is solving, and it's basically, and it is solving equations, but it's solving rational equations. Which basically just means that, again, if you're solving rational equations, like, everything we've been doing so far has been rational expressions, just doing everything with those. The only thing that's different with this one is that you're solving. And what we're going to do this one is kind of like we did in section 5. You want to multiply every term by the least common denominator. And pretty much from there, whatever you've got left over, you just simplify and solve. And I was trying to look ahead to see, I don't think, there might be just a tiny little bit of factoring here and there at the very, very, very tail end of it. But most everything that we're going to do, and this will be just in just a few cases, you might have to factor it to solve. I think that's at like the very, very, very back end of everything that you can do in 7.6. Okay, so here we go. So objective 1 says it's solving a linear equation with several occurrences of the variable, with variables on both sides. Okay. Again, just to save us time, that's why we got that sheet on here, so that y'all can go back and see, exactly how they word these when they go through the parts of it. All right, so we got negative 3 over 2y minus 7/5 equals 5y plus 7 over 2. Okay, so very first thing we have to do is, again, find out what that least common denominator is. And we only have 2 and 5. So if you multiply 2 and 5 together, your least common denominator is going to be 10. So all we're going to do now is we're going to go back and take every single term that's here and multiply by 10. Okay, and by doing that, 2 will divide into 10 5 times. So 5 times negative 3 is negative 15y. 5 will go into 10 2 times. 7 times 2 is 14. There is no fraction here, so it's just 10 times 5 for 50y. And for the last one, 2 will go into 10 5 times. 5 times 7 is 35. Okay. And sometimes there's simplifying. This one, there's really not, because you got variable and constant on one side, variable and constant on the other. So from here, there's no simplifying really. It's just solving this part out. I guess the simplifying was back here, canceling things out. But now you're just going to get y's to one side, numbers to the other. So for this one, I would say let's add, if you want to add the 15y here, and the 15 here. So we'll leave you with negative 14 equals 65y plus 35. And just subtract 35. That's a negative 49 equals 65y. And then to get the y by itself, just divide everything by 65. Okay, and for that one, 49, the only thing you can divide 49 by is 7. 7 doesn't go into 65, so for that fraction answer, it doesn't simplify, so that's your final answer for that part. Okay, now objective 1 and objective 2 are really similar, so that's an example from objective 1. The only thing different in objective 2 is, now the denominator is going to be the same. It's going to be 2 and 5 or 3 and 6 or 4 and 7 or something like that. The only thing that changes from objective 1 to objective 2 is the numerators change just a little bit. That instead of it just being 2 or 4 or 5, they change it so that now it's 9u minus 4. The numerator is just a little bit more complex. It still works out the same way. Still go through the exact same step. The only difference is that with the numerator being a little bit more complex, after you've gotten rid of the denominators, this part of the problem here is probably a little bit longer. May have to do one extra step in the middle there. Okay, you've got 6 and 7. First number they've got in common, 6 times 7 would be 42. Okay, so we're going to go back here and just multiply everything by 42. And even the one that doesn't have a fraction, you still got to go back and multiply it by 42. Okay, with the 42 and the 7, those will cancel out and leave you with 6, because 7 will go into 42 6 times. So you got 6 times 9u minus 4 equals 6 will go into 42 7 times. So 7 times 5u minus 4. And then 1 times 42 is just 42. Okay, a little bit of distributive property. 6 times 9 is 54. 6 times 4 is 24. 7 times 5 is 35. 7 times 4 is 28. And again, that plus 42 just hangs out behind it there. Now, one small thing you can do over here, you've got the 35u. Since you have these two just numbers together, if you want to go ahead and put those together, if you do negative 28 plus 42, that would make that a positive 14. And again, if you wanted to move those one at a time, and put those around, but anytime you've got two terms together like that, just go ahead and combine those two terms and get it down to 1. Okay, so now you've done everything you can do. It's just get the numbers to one side, variables to the other side, and then just work it out from there. So for this one, let's get rid of the 35u from this side, so we'll subtract 35u from both sides. Okay, that'll leave 19u here. Minus 24 equals 14. So we've got the variables to the left-hand side. Let's take the 24 and add it to the right-hand side. So that would cancel out over here. So we've got a 19u on the left. 24 plus 14 is 38. And with 19u over 38, if you divide them both by 19, that actually works out pretty nice because the 19s cancel. 38 divided by 19 is 2. So for that one, the u would equal 2. Okay, so 1 and 2, really similar. Again, the only thing that's different from objective 1 to objective 2 is the numerator gets a little bit longer. And all that really means is that the first one we didn't have distributive property. Once we multiplied the numbers, that was just the numbers. Objective 2, you did have to do a little bit of distributive property. But, it's just finding these two numbers, find out what that least common denominator is. And again, if you ever get stuck, just multiply the two numbers together. If the number happens to be a little bit bigger, that's fine. It'll still work out in the end when you solve everything out, and it's okay. So as long as you just pick a number that's big enough to get rid of the fractions, that's really the main thing that we're looking for. Okay, objective 3. Still the same setup. The only thing that's different in objective 3 is that it's got linear Still got a linear denominator, but it just simplifies out a little bit different. So we'll go right through this. All right, so negative 1 over x minus 7 equals negative 2. A little bit shorter. But to me, it's still that same thing that you're going to do here. Now, and this one's kind of a little bit, you only have one denominator, right? So if that's your one denominator, you're just going to multiply by x minus 7. So we'll take this side and multiply by x minus 7. And we'll take this side and multiply by x minus 7. This one's short enough we can just rewrite it because it's not very long. Okay, and same thing again, the x minus 7's cancel, leaves you with a negative 1. This one there was nothing to cancel, so we're just going to do distributive property with negative 2. Negative 2x plus 14. Okay, the x's are already over here on the right hand side, so let's get rid of that 14. And when we go back and divide by negative 2, then x is going to equal negative 15 over negative 2. Negative over negative makes that a positive. 15 over 2 doesn't simplify. Now, if you want to make it mixed number, you can. But again, on these, you do not have to make it mixed numbers. As long as it's in simplest form, improper fraction is okay. So if you want to leave that 15 over 2, that's absolutely fine. Okay, so that one's one of those where it looks like it's, you know, they kind of talk it up to be big, and then you look at it, it's like, oh, it's just two terms. Okay, you're still doing the same thing on those problems. It's just now you just have one side that's a whole number and one side that's got the rational denominator. Okay. Objective 4. Really, to me, it's not any different than objectives 1 and 2. The only thing that's different with objective 2 is that you do have a variable in the denominator. Other than that, it's the same problem as 1 and 2. But now instead of it being, you know, two numbers in the bottom and the denominator, now it's a number and then it's a variable. Okay, still doesn't change anything that you would do. You still get the least common denominator. Well, if it's a number and a variable, well then that's really easy because that is your least common denominator. Again, this one's fairly short, so we'll go ahead and just take every single thing here and multiply it by 7z. Okay, so take 7z and multiply it by every single term. The 2 wasn't a fraction, so it's just regular multiplication. It's just 2 times 7z. Well, that's 14z. Okay, for this one, it does cancel the 7 with the 7, so that one's out. Leaves you with 3 times z, so that would be 3z. And then on these two, the z's cancel. Leaves you with 6 times 7, and that would be 42. Okay. From there, again, just get the z's to one side. So I would say let's get rid of the 3z that's here and move it to the left-hand side. So it leaves you with negative, or sorry, 11z equals negative 42. And when you divide by 11, again, it doesn't simplify because of the 11. It's a prime number. There's nothing you can factor out of it. Just leave it as negative 42 over 11. Okay, so even with the objective, or with the variable in the denominator, it really doesn't change a whole lot of it because you're still just going to multiply by the numbers that you have there. Okay. Objective 5. This time, and it goes back to what objective 3 was. You've got expression in the denominator, but the difference on this one is that now you have the same expression that shows up more than one time, which really doesn't change anything. The only thing that was different on number 3 was you just had the one time it showed up, this time it shows up twice, but it's still the same denominator, so it's still really not anything too difficult because it's still that u plus 2 is your denominator. So if that's the only thing, that has to be your least common denominator. Okay, so if we go back and multiply everything by that u plus 2. Okay, and then start to cancel. That cancels that, leaves you with 7u. That cancels that, leaves you with 3u, and then just do a little distributive property on the end. So 8 times u is 8u plus 16. Do the 3u plus 8u, make that 11u. And then now, again, we're just going to take the 11u's, I would say move them to the left-hand side. So we've got negative 4u equals 16. And then divide by the negative 4, so u would equal negative 4. Okay, so first 5 objectives, it's the same thing. The only thing they do is they change the denominators, and they don't really change them that much. You know, they give you an expression, they give you 2 different numbers, but it's all pretty straightforward. The first time you get anything at all and it's not even really tricky, just something you just have to be careful of, is when you get to objective 6. Where now you've got 2 different linear expressions in your denominators. But even on this one, they make it where it's really fairly straightforward, because in objective 6, you do have different denominators, but again, you want to factor denominators really, but even numerators too if you could. You want to factor completely before finding the LCD. Let's try that one again. Okay, now again, there's not a whole lot on this one that you can do, but you can take this 2 that's in the denominator here and factor it out. Okay, so doing that, now you can see, all right, now I've got the same x minus 2. This one's got a 2, and again, technically this one would have a 1. So for your least common denominator, it would be 2 times x minus 2. Because you do have the x minus 2s. This one has a 2. This one's basically like a 1. Again, you always take the bigger number, start figuring out the multiple. So that one, it would be 2. Okay, now this is the part that you want to go back and multiply everything through. So we're going to go with this part. So we'll take 2 times x minus 2, multiply it by negative 5 over 2 times x minus 2, plus 3 times 2 times x minus 2 equals negative 1 over x minus 2 times 2 times x minus 2. Okay, and again, all that's going to happen is all your denominators are going to go away. This x minus 2 is going to cancel this x minus 2. That 2 will cancel that 2. So this whole thing is gone, leaving with just the negative 5. Okay, second term didn't have anything to do here, so that one is just 3 times 2 for 6. And you've got x minus 2. And on the right-hand side, that x minus 2 will cancel that x minus 2 and leaves you with negative 1 times 2, which would just be negative 2. Okay, so putting it all together. We've got the negative 5. We've got 6x. 6 times 2 for negative 12 equals negative 2. Okay, and then on the left-hand side over here, you do have a negative 5 and a negative 12. If you want to put these two together, that'd be a negative 17. And since the x's are on the left-hand side, let's go ahead and move that 17 from over here over to the right-hand side. Okay, but that cancels out. That'll leave you with 6x here and 15 on that one. Okay, dividing by 6 to get rid of it, again, the 6 is canceled. Now this one you do have something you can simplify, because with 15 over 6 you can divide both of those by 3. So that would make that 5 over 2. Okay, so again, the only big thing in Objective 6 that they get to is that you do have different denominators, but those are both just multiples of each other. You know, if you factor them out, they're pretty much the same thing. Objective 7 is pretty much just a continuation of Objective 6. Because in 7, it's still the same thing, but they just have you work on it just a little bit more here. Okay, same problem, just now the denominators are just a little bit bigger. But again, it's still the same thing. You still have to factor everything completely first. That before you do anything at all, you've got to go back and factor everything out as much as you can. Which, again, really it's just this one part that's back here. Okay, anybody want to take a guess as what the factors of 20 are that's going to equal negative 1? How about negative 5 and positive 4? So on this one, they kind of go ahead and they basically just kind of walk this thing out here for you. It's the same thing as this one, you know, where you had the same two objectives. This one, it's the same denominators that you've got here. You just got to factor this thing out, but it's the exact same numbers there. So if you were doing this, it's the factors of negative 20 where the sum would equal negative 1. So some of those, they kind of throw out numbers at you that you can hopefully look at it and go, wait a minute, well, that's 4 and 5. 5 times 4 is 20. If I subtract those numbers, then that's the negative 1. So hopefully it'll, you know, just kind of jump out at you there. Okay, so if you get your least common denominator now, it's x minus 4 and it's x plus 5. Okay, now, and here's one where if it starts getting a little bit longer like this one is, here's where I would start kind of maybe trying to save a little bit of time with it. Because once you've got it factored to here, you're going to take this one and multiply by your least common denominator. And again, all that's going to happen is the x minus 5s are going to cancel. That's going to leave you with 1 times x plus 4. When you multiply by the least common denominator here, the x plus 4s are going to cancel. That's going to leave you with 2 times x minus 5. And when you multiply by the least common denominator here, everything cancels, and that's going to leave you with just a 9. Okay. First number, no distributive property because it's just the one. You do have some distributive property here. And with the 9, well, it's just 9. So, okay, if you want to put a 1 there, you can. So basically, if you know that you're kind of bad about forgetting the 1, and some people are, some people aren't, just go back and put a 1 there so that on the left-hand side, you know you're going to do 1x plus 2x to make that 3x. Then you've got the negative 4, and then, or sorry, the positive 4 and the negative 10. Put that together to make that a minus 6. Okay, so if you've got 3x minus 6 equals 9, we're just going to add 6 to both sides. Get 3x equals 15. Divide those two, and then we get x equals 5. Okay, and objective number 8 might be the toughest one on here, I think, the way it's set up, this part. And it's not tough in the first part, it's really just the tough at the end of it. Okay, so the very first step on this one's really easy because you only have one denominator. So it's easy to figure out what the least common denominator is. It's not a surprise. It's the only denominator we have. Well, it's w. So we're going to go back and multiply every single term by w. So if we do that, just kind of saving some room and some time here. If you do w times w, that's w squared. If you do w times 21, that's 21w. Do 14 times w. Well, that's 14 times w. And when you multiply this one by w, the w's do cancel. And you're left with minus 21. Okay, so that objective 8 is really, really easy because there's only one denominator, which means when you multiply through, it's just you're multiplying by w, or x or p or t or whatever variable they give to you. They're all set up the same way in number 8. The biggest difference on this one is now because you have w squared, and you're going to solve this equation, this is where we go back, and I think I mentioned this, that if you start solving an equation, whatever your highest power is, that's how many answers you're looking for. So when you do this one, you're looking at w squared, you're looking for 2 answers, which means now we're actually going to have to do some factoring on this thing. So what we're going to have to do is we're going to have to move all this stuff over to one side. So we'll have w squared plus 7w equals negative 21. And then we're going to add that 21 over to the right-hand side. Okay, I wrote one of these numbers down wrong. Change that to 24. And that's what it was. That's supposed to be a 24. So if we do 24 minus 14, that's not 7w. That would make that a 10w. And same thing here, change that to a 10w. Okay, sorry about that. Okay, so change that first number back here to 24, instead of 21, to get us to here. Okay, now once you get here, you should have something that you can factor. So what are the factors of 21 that equal 10? Well, it's not 1 and 21, so it's got to be 3 and 7, right? So that's W plus 3 and W plus 7. Okay, and the only thing you do is that with this part is that once you get it in factored form, then just go back and take each parentheses and set it equal to 0. So we get W equals to negative 3 and W equals negative 7. Okay, let me give you one more of those with some correct numbers that I didn't quite mess up, so we can make sure we get. Okay, so x plus 32 over x equals negative 12. Okay, and again, there's not a complex denominator. The denominator is really straightforward because it's just x. So we're going to go back and multiply every single term by x. Okay, so if you do that, x times x is x squared. These x's, when you multiply this times x, those are going to cancel, leave you with a 32. And on the end here, do negative 12 times x, that's a negative 12x. Okay, and again, for this one, because you start off with x squared, it makes it, if that wasn't there, you could just divide these two numbers and you're good to go. But with x squared, it's a factoring type thing, so basically you're going to have to pull all the terms to one side. So we're going to add this 12x over here. Okay, and what's the factors of positive 32? This sum would be positive 12. Well, it's not 1 and 32, it's not 2 and 16. The good news is on this one, they're all positive, so it's got to be 4 and 8. Okay, and then to go the one extra step for solving in this part, again, you just take each parentheses and set it equal to 0. Which pretty much just means once you get there, you're just going to add or subtract the numbers away, which you're just going to wind up changing the signs. So that x would change to a negative 4, and that x will become a negative 8.